Hello and welcome to Tribe Topper. In this video, you are going to learn some elevator problems and connected masses. So whenever you are given the elevator problems, you have to analyze whether it is going up or going down first of all. Now in this particular case that I have chosen, the first one is elevator is accelerating upwards. This automatically indicates that the resultant force, which we write as F net, is upwards, right? Because acceleration is always in the direction of the resultant force. And when the resultant force is upwards, it means my upward force will be greater than the downward force. Therefore, how will you formulate the equation? The upward force is tension minus the downward force is the weight. That gives you the net force, which is mass. That gives you acceleration, right? Just take care. Upward acceleration means the resultant force is upwards. So the tension is the greater force in this case minus the weight downwards gives you the net force MA, which is upwards. And from here, you can now find out, therefore, what will be the tension in the string. That's MA plus MG, which means M can be common and A plus G. This is the case of an elevator accelerating upwards. So obviously, if the elevator is accelerating downwards, then that would mean my resultant force, that is net force, will be acting downwards. So this time my downward force is greater than the upward force. You can also make that out from the length of the arrows here. So mg minus T, right? Mg weight downwards is greater. From that we subtract tension T upwards, and that gives me the net force MA, which is acting downwards. So therefore my equation becomes T is equal to mg minus ma, or m into g minus a. So this time the tension will be less than the weight. In the previous case, the tension was greater than the weight. So just from the simple fact that direction of the acceleration is going to be in the direction of the net force, you can easily formulate an equation as upward minus downward force or downward minus upward force depending on the given situation. And now let's talk of these joint masses or connected masses. As you can see here in this situation, this is one mass mg, which is going to just move down because the acceleration is marked here to the downward direction, and here it is marked towards right. So mg is pulling the mass downwards. That means this mass, which is resting on the table, is going to move to the right. Now let's talk about the forces. I'll mark this as mass 1 and this as 2. So for the first mass, the weight mg is balanced by the normal reaction. They have no contribution in this motion, so they just simply cancel out. The only force that is pulling the mass 1 to the right is tension in the string, and the tension in the strings, both the parts, is going to be same because these are connected masses passing over the pulley. So tension here is going to be equal whatever tension is here in this part. So this tension and this tension will be equal. So for the mass 1, the only force that is acting is tension. It is pulling the mass m to the right, and that is equal to the net force ma, right? This is towards the right. And for the other mass m2, it's hanging vertically. The only two forces are mg and t. Because it's the acceleration acting downwards, so we will have mg minus t is equal to ma. From the first equation, I'll use this value of t, and I get mg minus ma is equal to ma. I'll take this mass to the other side. I get mg is equal to small ma plus capital M times a. Acceleration can be taken common outside, is equal to mg. Therefore, what's the acceleration of this system? It's weight mg over m plus m. So when you have a connected mass, how will you find the acceleration of the system? By again writing just the equations for the resultant forces. So the resultant force on the top one is tension, which pulls it to the right, so that is ma, and for the bottom mass, which is hanging vertically, the resultant force is mg minus t, and that gives you ma. So these two equations combine, we work on them, and we figure out that acceleration of this combined mass, which is going to be same in the two parts of this string, that is mg over m plus m. Both the masses will move with this same acceleration. I hope you've understood all of this. In the next video session, you are going to learn about the frictional forces and translation equilibrium.